Students, are you ready? Right, probably I'll just go through this in a very fast pace. Right, so what is statistics? Just some techniques or procedures to process the data so that the data becomes something meaningful that people can understand. Okay, right, so we went through a few pairs of words. The first pair of words is the population and sample. Right, so the population it consists of all the objects of interest in our study. Depends on what is our study. Sample is just a small portion of it. So why you dive into sample? Because this is usually too big for us to handle. So we have to pick up some randomly. And from there, we can understand the characteristics of this. Okay, once you understand the characteristics, then you can find out some numbers and all these that you have found out, you try to describe here. We call that descriptive statistics. And the number you find from here, they are all called statistics. Okay, and what you're going to do with this is you are using this number to estimate what you want to find out. You are interested in finding what is the market price of a bubble tea, a regular bubble tea, for example. So from there you get $3.50, and you try to use this to estimate the population average, which we call parameter. So when you are at this stage, you are doing something called inferential statistics. We went through 4 different types of sampling techniques. Since sample is so important, so there must be a fixed a recognized way of we doing sampling. Simple random is just a very simple, like the lottery style, the one that you saw on TV. Yeah, in programs, they usually try to show you one of the receipts has been selected as a win, or there's a number dropped out. What is that number? So this is the simple random sampling. Systematic, you have to group the population into the number of groups, the number of people you want to select. You want to select 8, then you group them into 8 groups. Then from each group, you're going to pick up 1. So you're actually using every case individual. Now, when are you going to use this is mostly on the production side. So when, for example, you have been eating McDonald's for so many years, so you see that before you get the McDonald bun, for example, fish fillet to you, there is a bun and there's and there's some other ingredients, right? So how does the bun process? The bun is actually packed in individual plastic bag. So they are actually produced in a production line. So of course, the bun will be checked before it's delivered to each McDonald outlet, so that make sure that whatever you get uh, um, is acceptable to you. Yeah. So the quality control operator will do a checking of these buns periodically. So maybe every 100 buns, every 100, okay, have been produced, then one bun will drop out. Then someone over there will just pick up the bun to check. That is a quality control operator. Okay, so to make sure that the bun that has been produced is good quality, is up to standard. So this is how it says every 100, every 200, or every 5 or what. Stratified, you use the common characteristics. Yeah, you group things, but with the common characteristics by the major of your study. So, for example, there are 100 over of you. I'm going to group you into groups. The grouping will be by your field of study, your major. Maybe some of you are doing accounting. Yeah, some of you are just doing a general business. So this can be a grouping. Any sort of grouping where you have a common characteristics, a sort of characteristics where you group people or you group the population is called stratified random sampling. So from each of these groups, which you call that strata, you're going to pick up some samples. Cluster, the grouping must be geographical area. It can be by building, it can be by streets, it can also be by rooms. For example, in Marina Square, you have so many rooms. So If there are how many rooms? Probably, okay, let's say there are 25 rooms. So I'm going to pick up 5 rooms out of the 25. That is by room, right? So as long as by location, you call that cluster sampling. The last 8 that we do is a qualitative and quantitative. Qualitative, not numbers. Quantitative are numbers. Numbers can split into 2 again. This number do not have decimals, okay? And this number can have decimals. Do not have means cannot have, yeah? This one can have decimals. 2.59, that this one is a 2 or 5. It cannot be 2.5, or cannot be 5 point something. The last one we have is a data level management or measurement. So these two belongs to qualitative. They are not numbers. Yeah. So there are some questions about this level. I just want to elaborate a little bit. Now, every variable will go from here to there. It will start from this level. If you fulfill this level, it will go on. You fulfill this level, it go on. If you fulfill this level, then it go on. Okay. So for example, you have what do we have this now? Yeah, I pick up one. Hair color and temperature. Okay, we pick up 2. Hair color. Where is hair color? It goes through here. Does it fulfill ordinal? Hair color? No. So it is nominal. Okay, temperature. So it goes through here. Fulfill? Yeah, this is label. Nominal is just a label for something. So for example, today's temperature is 29. So it is telling you that today's temperature is 29. So you know some information out of that. So it is a label. And you ask yourself, is temperature ordinal? Today is 29. Yesterday is 27, let's say. Is yesterday temperature lower or higher? So you can find out. So that is a lower, higher, bigger, smaller that you can order. Okay. If yes, then you go on to the next level. Can you find a difference between the two, 27 and 29, in a very precise measurement? Yes, 2 degrees Celsius difference. 27 and 29 is 2 degrees Celsius difference. If you can find out the difference, then you say, okay, yes. Then you go to the next level. The ratio level must have a true zero. You ask yourself, is there a true zero in the temperature? That means, does the temperature starts from 0 point? The answer is no. Why? Because temperature can go below 0. 0 must be the starting point, then it is a ratio. So temperature have negative, so it does not fulfill ratio requirement. So it stays here. Okay. How about the weight? The weight goes through here. Yeah, it's nominal. It goes through. Then yeah, weight 2 persons or two different boxes. We have different weights, so you know which one is heavier, which one is not. Then it goes to the next one, interval. You can find out the difference between 2 boxes. Then you go to the ratio and check is weight having a true zero. Yes, because the starting point of a weighing machine is always pointing at 0. Yeah, the starting point, that is a start point. It's the true 0. So if ratio yes, then it's ratio, right? So that's how you find out which level it is. That's why you see there's a lot of yes, 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 until you find a no, then it's stuck here, interval. Yes, 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 it's stuck here, so it's ordinal. Okay, yes, 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 then it's ratio. Up to here, then it's interval. Okay, right. So now I'm going to do the second half. Second half probably will be easier for some of you because you may have seen that earlier in your previous studies in your secondary school, even though you don't really define that as a statistics, but something for your knowledge, yeah. And also there are something that you see on newspapers, in magazines, where you see tables and graphs, so they are more user friendly to you, right? So let's see what we have. Okay, there are a lot of explanation and definition here, so I will just keep it and I explain through the examples. Right, so there's an example here. An advertiser asks 200 customers how many days per week they read the daily newspaper. So you collect from a sample of 200 customers. Probably you stand outside a mall and you just continue recording. The first customer that you approach, the first one, you say how many days you actually read newspaper in a day, in a week. Then the person say 3 days. Then you write 3 days. Then you approach another customer. You ask the same question again. How many days in a week that you read newspaper? The person say 7. So you record 7. So you do that up to 200 people. Okay, so how many different numbers you can have in the number of days here? You are just asking about a week, right? So a week can be 0 day, 1 day, up to 7 days. So you just list down all this number and you count how many zeros here, how many ones here, how many twos here, then you record down here. Okay, so 200 people, right? So you must total up to 200. So this table is just a very simple table. You call this frequency distribution table. It just show you the information that you need to know, number of days read, and you can give it a general name called class or category. And the frequency will show you how many times this number appears. So how many times one appear? You see one here, right? So here we have 2 ones, but there are more, correct? So there are 24 ones. 18 of the customers say 2 days. 20 of the customers say 4 days. You can also continue to find out the proportion. So if I were to ask you how many percentage of the customers do not read newspaper at all? 44. So 44 out of a total of 200. Okay, 44 out of 200. What's the proportion? 0.22. If you want to find out the percentage, you multiply 0.22 by 100%, you get 22%. So you can say 22% of the people in the sample report that they read the newspaper 0 days per week. Right. So this column is called relative frequency with reference to the total. Okay, every time you see the word relative, that means the number is with reference to the total. Another example, a real estate broker conducted a survey of 16 estate agencies. These people sell house and buy houses on behalf of another person. Okay, so they just help with the transactions. So they collect data on the number of real estate transaction closed last month. You know, selling house is not so easy. You won't be selling houses every day, right? So there are only like 0 up to 4 transactions done in a month, right? So, and this is a raw data. Raw data means the data that has not been processed. You just record down and you have not done anything to it. 0, 2, and so forth. So how do you put it here? You know, over here the smallest number is 0, the biggest number is 4. So you just list down 0 up to 4. And how many zeros you have? You just basically do this counting. 1, 2, 3, 4, 5. That's how you get the 5 here. Okay, right. So 5, if you want to find the relative frequency, that will give you 5 over 16. And you get this. So if you want to know how many percent of the agent did not do any transaction, no transaction has been transacted, it will be about 31.25%. Okay, same thing for the rest. And this is called relative frequency. So what you have seen here, the number here is very small, right? So if the number here range from 0 up to 100, then you would not want to do this in this way. Okay, we are going to group them into a group. And also, if you have continuous data, for example, 0.5, 0.75, 1.2, 1.6, those numbers you can't list them down one by one like what you have seen. So you have to group them into a group, which we call that group data. Okay, so group data are organized in classes as well. These are let you see this first. This is called the class. Okay, this time we have a class which have a single number inside, but if you have a group, distribution, then you have a group of numbers inside. So this class will consist of 10, starting from 10 up to below 20. So it's 19.9999 is still within this class. 20 goes to the next class. Okay, so this is called a class. How many classes we have here? 1, 2, 3, 4, 5 classes. Okay, same thing for you can find out the frequency, then you can find out the relative frequency. So if I were to look at this number, let's say you have a list of number here and ask you to put inside this table. How do you do it? 10 and under 20. So anything below 20, I'm going to count 1, 2, 3. 3. Okay, 1, 2, 3, 4, 5, 6. Then I get 6. Right, that's how you find out all the numbers. Now, the problem is, how do you know how many classes you need to create for this set of numbers? You have a set of numbers, and suddenly you come up with a table already, yeah? So how do you know how many numbers, how many classes you need, and how big is the class do you need? Is the smallest number is 12. How do you know that you have to start from 10? Okay, so we'll look at that. Right, so we were here, right? Okay, now you see that all these classes, they are mutually exclusive. That means there's no overlap. 20 cannot appear in the first class, cannot appear in the second class. Also, it has to be only one of the classes that have 20. Okay, this is called mutually exclusive. And it has to be all inclusive. That means it covers all the data points that you have. Your smallest can go in, the highest also have a class to go, right? And the classes should be of equal size. You see just now it's 10 to under 20, 20 under 30. So everyone is the same width. We try our best to avoid empty classes. That means the frequency shows a 0. Sometimes you can't avoid 1 or 2, which is 0, but you cannot have many of the classes which are 0, 0, 0, which is not good. Okay, right. So we're going to look at how do we define the number of classes, how do we find the class width, then we decide what number to start from each class and how big is it, the class width is how big is it. Okay, the boundaries is from where to where, 10 to under 20, that's the boundaries. Okay, then we find out what's the frequency. So the number of classes that you have to find out is very important, because if you put too many classes, then you find all these things happening. There are too many classes, then you see that the graph is not actually giving you any information. You can't see anything from this. Same thing if you find too little classes, then you find that there's only 2 bars, nothing to explain, yeah? Right, so how many classes is optimal, the best? We are going to use a rule. This rule is called 2 to the power k rule. 2 to the power of k must be greater than a number. Now today you will be introduced with the first symbol in statistics, which is called the n. What is n? N is the number of data values. For example, if you have 20 numbers, the n will be 20. If you have 100 numbers, then the n will be 100. So we are going to find out, let's say we have 20, right? So just now the number that, the list of number I show you is 20 numbers. So we are going to find out how do you do this 20. Okay, so n equals to 20 will give you 2 to the power of k. 2 to the power of k must be equals to 20. Okay, now I'm going to find out when k is 1, when k is 2, when k is 3, what's the value? When k is 1, 2 to the power of k will be 2 to the power of 1, right? How much is it? 2. When k is 2 will be 2 to the power of 2. 2 to the power of 2 means 2 times 2 will give you a 4. 2 to the power of 3 will give you 2 times 2 times 2, 8. Okay, now continue. 2 to the power of you get 16. 2 to the power of you get 32. Okay, you can just multiply 2. Okay, now you look at that. You need this to be fulfilled. When do you fulfill this? What value of k you fulfill this? 32. Okay, 16 not enough, right? 32. This one also you fulfill, right? But what does the thing say? K is the number of classes and is found to be the smallest number, so that this is true. The smallest will be this. Yeah, you cannot take 6, 7, 8, 9, 10 because they are all more than 20, but the smallest which more than 20, which is 5. So what's the k value? The k value will be 5. Okay, right. Now if you look at the number 5, okay, let's I move to the next slide. This is a number that you saw just now with the table, 20 of them. Right, so the number of classes is 2 to the power of k more than or equals to 20, so you get k equals to 5. Okay, so there's my mouse. Right, k equals to 5. Now, you have to consider now is you have 20 numbers from here up to here. You are going to split these 20 numbers into how many groups? Into 5 groups. Okay, into 5 groups. So where is these 5 groups? How big is this group? Then you have to find out. The biggest number is 58. The smallest number is 12. Okay, so what's the difference? 46. And you're going to get this 46 divide by 5. I have 46 different figures here. You can have a 46 different figures, and I'm going to split up into 5 groups. So how big is one group? Then I get 9.2. So usually try to round off to something which is easy for you. Round off to a whole number. Yeah, the nearest 9.2, you don't go to 9 because you need at least 9.2. So you round up to the next whole number will be a 10. Okay, that means this is the width. This is the width, right? So 10 to 20. 20 minus 10 is 10. Okay, or you look at the first number, 10 and 20, the difference is 10. Right, so that will be the class width. Clear? That the next thing is, you know every class must have 10. But which number you are going to start off with from the very first class so that you can continue on with the same. The smallest number is 12. The biggest number is 58. So how do you decide which number to start off with? Right, it's up to you. You can start off with 12, nothing wrong. Just that it's not so nice. Yeah, it is not so easy to read. If you start out with 12, for example, if you start out with 12, then it ends up with 22, then you start with 22, end up with 32. So it's not so easily absorbed by our mind. So you just choose a number which is convenient and nice to see. So we start out with 10. Okay, 10 to 20, then 20 to 30. So this one I explained that under, that means the under 20 means does not include 20. It's up to 19.9999. Okay, so you put under 20 because this is weekly expenditure. Weekly expenditure are money value. Money can have decimal. So you are spending, you can spend 19.99, right? So it still include below 20. Okay, right. So Right, that's how you figure out this. Now let's see what else you have here. You have the range, you have the classes, you have the width, and you have the boundaries. The 10 and 20, 30, 40, 50 is called the boundaries. And another one which you need to know is the midpoint. Midpoint means in the middle of the class. The middle of the class. 10 and 20, what's the middle of the class? 10 plus 20 divided by 2 is 15. 10 plus 20 divided by 2 is 15. So 15 is the midpoint of the first class. Right, so let's have a look at the next slide. What you have just now is the expenditure. Not many values, 20, but you cannot list down every number as one because there are decimals, right? So it can be decimals and quite huge a range from 12 to 58. So it's not convenient for you to list down 12, 13, 14, 15 up to 58. So you group them together. That is continuous data. For this particular one, you will have discrete data. The customer are asked, how many DVD movies do you own? So what can you respond as an answer? You can only respond in a number. I have 2, I have 4. I cannot tell the person I have 2.5, right? So this is discrete numbers. But this discrete number will have a big range. You see that? What is the smallest number here? 0 is the smallest number, right? There are quite a number of zeros here. And what else you have? What's the biggest number? 30. Okay? So the question says you have 230. With 230 data points, how many classes do you need to do? Okay, 230. So just now we stopped at 64, I guess. Okay, let's find out the number of classes, yeah? So we are going to do this again. 2 to the power of k must be greater or equals to n. So now n is 230, so I'm going to write this 230. Okay, then the next thing is I'm going to find out. I don't start from 1. I don't start from 1. 2 to the power of 5 just now will give us 32, right? Not enough. 2 to the power of 6 give us 64. Still not enough. 2 to the power of 7 give us times 2 again 128. Not enough. 2 to the power of 8 times 2 again 256. Enough? Yes. So what's the value of k? 8. Okay, k is 8. Now you are going to split this 0 to 30. There are the range of 30 down to 0, right? 0 to 30, there are 30 numbers. You're going to split that into how many classes? 8. So what did you get? 30 divided by 8. You get 3.75. Okay, again 3.75 is not a good size. It's not a good width because it's very difficult to manage. Yeah, so find out a nearest number which is bigger than that. Whole number 4. Okay, so that means we're going to have a class width of 4 with 8 classes. Then the class width is 4. Then you look at the data, the smallest is 0, the biggest is 30. So of course we're going to start with 0, right? We are not going to start with negative because it's number of DVDs you have. So the smallest class will be 0. 4 means the next class will start from 4. Okay, and the next class will start from another 4. Clear? Now, using what you have seen earlier, you have under 20. For this, do you need to put under 4? Do you need under 4 here? The answer is no. Why? Because you know the biggest number you can have here is 3. You cannot have any DVD. How many DVDs you have? You say I have 3.2, 3.4. So there is nothing above 3. So we are not going to do that. Okay, where we just put up to 3. Clear? Okay, so this is the whole thing that I explained just now. You have 0 to 3. Then you have 4 to 7. Then you have 8 to 11. Then you can 12 and so forth. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8 classes. Then you know how to get the frequency by just cancelling the counting from the group. Now don't worry, in the exam we won't be giving you 230 data to put into a table, which is too much for you within that short time frame, right? So if you have big data values, usually the computer will come into play. But here we just need to give you probably 30 or definitely less than 40 data points. So you can put inside this table to know that how this is be done. Yeah, this is how computer do it. So you just experience that this is how it's done. So next time when you want to ask a computer to do something for you, you know how to command the computer or any software, right? So once you get this, the frequency done, the total is 230, and you can find out the relative frequency. The relative frequency will be 60 over 230. Okay, so everyone divide by 230. Now we are going to go to another 2 columns, which is called cumulative frequency or cumulative relative frequency. So the relative means to change into decimal. So what is cumulative? Now before I explain that, you look at this. 50. 50 customers says what? You are asking them, saying that how many DVDs you have, right? So the response to that 50 is they have 4 or they have 5 or they have 6 or 7 DVDs. Okay, so now if I were to change my question, say that how many customers are having 4 to 7 DVD movies? 4 to 7 DVD movies, how many of them? 50. Okay, but if I change my question into how many customers have 7 or less DVDs? 7 or less. 7 or less can be 7, 6, 5, 4, 3, 2, 1, 0. Okay, so how many of them? It will be 60 and 50. Okay, 60 and 50. So the relative frequency, okay, how many percent? 21% say so, 21 and 26% say so. So what is the total number of percent say that they have 7 or less? That will be total of this. Okay, now this column, the 4th column, the cumulative frequency, will give you this information. How many less than 7 or less than or equal to 7? 1, 0. Why? Because you have 60 and 50, right? So this column is actually just adding, keep on adding until the last one, you get 230. Okay, so this is called cumulative frequency. You keep adding it. You can also find the relative of cumulative. Okay, that will give you the same. Now, how do you find it? You just take this one, divide by 230. Then this one, divide by 230. Then this one, divide by 230. Okay, so at one glance you know that. So I ask you that you're going to add this, right? This one will be 0.478. Okay, 0.478, which is exactly this number. So if I were to ask you how many percent, how many customers having 7 or less DVD, you say there are 110. There are 110 of them. And what's the percentage? It will be 47.8% of the customer have 7 or less DVDs. You can also say 47.8% of the customers have less than 8. Okay, 7 or less is the same as less than 8. So in the exam, we will ask you the meaning of this. So you have to pick up. What is the third figure under cumulative frequency? The third one is 157, right? So what does it mean? So you say 157 customer in the sample owns fewer than 12 DVD movies. Okay, it can be less than 12. Okay, less than 12, or you say own 11 or less DVD. Two ways, right? Okay, now this is another example where you have 1,220 calls now. There are 1220 data point. What is that? This is the time needed for response teams to reach their destination in emergency situation after leaving their stations. You know, response teams, this emergency team, how do they respond? They have to be there at the destination within seconds. So all this time is seconds. 0 to 30 means below 30 seconds. They arrive at the place already, right? So, and this is the data that they have. So just to understand the set of data here, you have relative frequency 36 over 1220, and you have a cumulative relative frequency. Okay, cumulative relative, that means this is 36 over 1220, right? Then you have 36 plus 68. Then you have 36 plus 68 plus 195. Get it? Right, it's the same. Now, even though this is good, so if you look at this, if I were to give you this as a data, my goodness, what can you say about that? You can't see anything except you say the minimum is 0, the maximum is 30. And the rest you cannot comment much because you've not analyzed or you have not summarized or organized the data, right? So, but once you have organized it in this way, you start to see that, oh, that will be the most of the customer will have 0 to 7 or probably 0 to 11 DVDs, or maybe 0 to 15, yeah, 15 or less DVDs, right? So, and you can find the percentage, you can find the cumulative relative frequency and the percentage, right? So 1220, even more, right? So you cannot see anything if you don't put it up in a table in this way. But once you have put up the table in this way, you can see that most of the customer are within this range. Sorry, not customer, most of the response team arrive at the destination from 60 to under 210. You can see something here, but it will be good if we can convert it to graphs. Then you can see the pattern even clearer. So we are going to look at 3 graphs here: histogram, polygon, and ogive. Okay, cumulative is called ogive. Straight away to this histogram. Right, so this is a histogram. What does histogram look like? It consists of bars, and the height of the bars correlate with the frequency. So this is 36, okay, and this is 68, and so forth, right? And this side will be the frequency. Bottom will be always the data itself. Now you see that for this particular one, 0 to under 30. 0 to under 30. Under 30 can be 29.99 seconds. So between the under 30 and the next portion, which is a 30, you hardly find any gap in between. So they are sharing the border. You share the border 0 to 30, 30 to 60. Okay, so you just continue. You notice that there is no gap in between the first bar and the second bar. This is how you draw histogram. Next, called polygon. Now, what is polygon is you are going to construct this using the midpoint. Okay, that means you are going to use the middle. Use this middle, 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 all the middle point. You connect with lines. 1, 2, 3, 4, 5. Okay, so this is how you draw polygon. So when you pick up the center, then you will not be labeling the 30 and 60 and 90. In fact, you'll be labeling what? You'll be labeling the midpoint in between, which is 0 and 30. The middle is 50. Okay, you'll be labeling this. This is 45. Okay, so this is how you look at. This is 36. The first number, 36, is above 15, the middle. Okay, so how you get the 15 is the midpoint. 0 plus 30 divided by 2. Right, so from the first one all the way to the last one, the first to the last, you're done with. But you notice that there are two extensions from the beginning and the end, right? So what is the extension? That is a feature of a polygon. You must have these 2 points anchored on the x-axis. Right, so how far would you anchor this? It has to be the same distance. From the first point to the second point, this is the distance. Okay, so from the first point to the first anchor will be the same distance. You cannot draw too far away. Same thing here, from here to here is this distance. So from here to here, it will be this distance also. Yeah, so this is a feature. The 2 ends are the feature of a polygon. Without these 2 ends, the whole graph, you can imagine, the graph has no, it seems like it's hanging in the air. Okay, it will be just a line graph, not a polygon. Let's look at the last graph. The last graph, we use the cumulative frequency. The first one is 36, the second one 36 plus the next one, and the next is this. Right, so when you draw, you are drawing according to what I asked you just now. How many of the response teams arrive at the destination below 60 seconds? My focus is this, below 60 seconds. So you say there are 68 plus 36 of them, so it's 104 below 60. So when you plot the graph, 60 becomes an important number, not 30. Okay, so it will be 1, 0, 4. So the 30 will be 36. You see that you're only focusing on this, the upper limit or the upper value of the class. Okay, or the upper boundary, you call that. So for this particular module, upper limit, upper value, upper boundary, they are all the same. Okay, now the first point is this, the second point is this. Until you finish everything, that's the last point. But you notice that there is also extra. Okay, that extra is a feature of this ogive. You have to connect it down to 0. Okay, not this 0, right? No, not this 0. Okay, so it is this 0. You have to connect it down to 0. So the 0 point does not need to start from the origin. It can start further to the right. It's okay, but it has to start from 0. So it's like a running course. Start from 0, get set, then you run. Okay, so this is the 3 graphs. For this 3 graph, you see that we use frequency. All these are frequency. So the next 3 graphs that I'm going to show you, it has the same thing. Does it look the same? Same, right? But we are using the relative frequency on this side, which makes the whole graph looks a bit complicated. Yeah, but percentage sometimes will be more useful than the frequency. Okay, so just to show you that you can plot frequency, you can plot cumulative relative frequency, or you just put relative frequency on this side, relative frequency. The shape of the graph won't change. Let's look at another set of the way we do it. Remember, we have two ways we can do this. We can have under 30, and we can have 0 to 3 without the under, right? So if we don't have the under, this stops at 3. The first one start with 3. The second one start with 4. Okay, so it seems that there is a gap there. So for this module, we don't separate them into different gaps. Okay, we are just classify them as a category. This is 0 to 3, or 0, 1, 2, 3 goes inside here, 4, 5, 6, 7 go inside the next one, right? So this is how you do it. The difference of how you label it only. How you draw the graph is exactly the same, no change. How do you do this? It's also exactly the same. 0 to 3, what is the midpoint? 1.5. So 1.5. So the first point is 1.5. The rest is the same. Come to this one, ogive. This is still ogive. You're still using the top limit. Okay, so 3 is the first one, 7 is the second one, and so forth. Everything is the same. Okay, right. Now, how many types of shapes can we have? This is just a few commonly seen shapes. Okay, so when you draw any histogram or any graph or polygon or histogram, you will have one which is more common. One is the bell shape. Okay, bell shape. It looks like a bell. Both sides are balanced, but you would have something which is not so balanced, where you have a right side which is longer, but the left side just go up very fast. Okay, that is called right skew. This is right hand side, so it's called right skew. This one will take a long time to climb up, then come down very fast. So that is a left skew. Okay, the longer side will be called the left skew. You may have two peaks as well. These two peaks doesn't need to be same height. One higher, one lower, that is okay. But as long as you can see that it is there is obvious two mountains, two highest point, then you call bi. What does bi mean in English? In English, bi means two, right? Okay, so these are the normal shapes that you would see. Let's have a look at the exercise here. The following data represent the daily number of cupcakes sold during a 2-month event. Number of cupcakes sold. Construct a group frequency distribution for the data. So how many data do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 30. You have 30 data points. So what is the smallest number you have? Okay, all three digits, right? So 100 is the smallest. The maximum number? One, 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 two. Okay, this 127. Yeah, nothing is more than 127, right? Okay. You have 30, so n equals to 30. So we're going to find out 2 to the power of k. 2 to the power of k must be more than equals to n. So you need to find out 2 to the power of k must be more than equals to 30. So based on what we have gone through so many 2 rounds already, 2 to the power of 4, let's say I start with 2 to the power of 4 is 16, not enough. 2 to the power of 5, 32, enough? Yes, this is more than 30. So what's the k value? Okay, k is 5. So when k is 5, we have so many numbers here. The biggest number is 127. The smallest number is 100. And all these number, you are going to put them into 5 classes. Okay, so 5 classes. 127, 27 divided by 5, how much you get? So again, we try not to have any decimals in the class width. We are going to round up to the next number. So it will be 6. That means the first number and the first number, the lower number of a first class and the second class and the third class will have a difference of 6. Now we're going to decide what number to start up with. The smallest is 100. I think it's good to start with 100 because 100 looks nice, right? So let's start with 100. 1, 0, 0. So the next class will start from plus 6, 0, 6. Then the next one will start from 1, 1, 2, and 1, 1, 8. Okay, so there are two ways you can construct the table. You can construct the table with the under, or you construct a table with no under word. So for example, if we were to construct the table with the under, then I will put up to 106. Okay. Then the next one will start with 106. Or we can start out with 100, 106, 112, 118. You see up to what number? This one start with 106 up to 105. Okay, this one start with 112, so the up to 111. So there are two ways you can do this table. Depends on what has been started for you in the exam. You'll be told what to start off with. Okay, right. So another, when you are doing practically, when you have data and you're going to construct this table, and what you can look at is this discrete or continuous? If it's a discrete, you use this. Okay, you don't have under, you don't have under. If it's continuous, then you have under. This one you use for continuous. Right, so let's see what we have. Find the range. 127 minus 100 is 27 number of classes. This one, okay, class is 5, and the class width we found out already, and this is the boundary of the classes. And if you want to find out the midpoint, it's the middle of, okay, why, how do you know that it's so? You have to look at this. 100 to 105. Okay, so this is given to you in the question. You just follow this pattern. And what is the midpoint? The midpoint will be 1, 0, 100, 100 plus 105 divided by 2. So we get 102.5. Right? Okay. So next one. 111. Continue with that. 1, 1, 2, 1, 1, 8 plus 6, yeah? 1, 2, 4. So if this one start with 118, that one will be ending with 117. This one will be ending with 1, 2, 3. This one will be 1, 2. Okay, the last one you have no reference already, but you just look at that. How much you add 5, so it's 1, 2, 9. So find the average here, you get 108.5. This is 1 plus another 6, 4.5. This one will be 1 and another 6. Okay, now come to frequency. This is something very important. You are going to put out all the numbers inside this table, right? So the first thing you do is, we are not going to remember 6 different numbers in 100, 101, 100, 200, 300, 400, 5. So by the time you finish doing it, you feel very tiring. Yeah. So what you do is, the faster method is, it looks slower, but actually it's very clean and fast. So you just go through one by one. 112, 112. Where is it? 112. Okay, here. So you put a 1 here. 127 is here. So you put a 1 here. 109 is here. So you put a 1 here. 110, 110 you put here. Okay, 117, 117 is here. 105, 105 is here. 107 is here. 114 is here. 106 is here. 116 here. 110, 1, 2, 3, 4, 5. Okay, the next one we put it like that. 104 is here. 120 here. 120 again. 114, oh sorry, 114, 114 is here. Okay, 1, 2, 3, 4, 5. 100 here. 120 here. 112 here. 118 here. 116 here. 109 here. 112 here. 115 here. 110, 110 is here. 108 here. 121 here. 111, 113, 117, 114. Okay, now you count. This is 3. This is 5 plus 3, 8. 12, 5, 1. I think we missed out 1. It's 1062111. Okay, so I think we missed out 1 just now because I'm just toggling with this pen. Right, so that should be a 9 here. So I do not want to continue to repeat all over again. So if you do by paper, it will be cleaner. You see this one is keep flipping. It should be a 9 here. Then you total up 9 plus 3 plus 12 plus 5 plus 1, you get a 30. Okay, and this is called the total. Right, so the next column that you're going to do is relative frequency. 3 over 30, 9 over 30. Okay, you don't need to write that, but I'll just write for you for your reference. 0.10, 0.30. Okay, then this one will be 0.40, 0.17, and 0.03. You don't need too many decimal, 2 will be enough. So you will get 1.00 over here. Sometimes you end up with 0.99. It's okay because you have a lot of 33, 33, 33, things like that. Yeah. Then also you sometimes you get 1.01 because you end up with 17, 27, and 67, all the rounding up, right? So it is okay, but most of the time you get 1.00. Right. So next thing is you're going to do is cumulative frequency. Cumulative frequency you are going to add. So the first one is just a 3. The next one will be a 3 plus 9. Okay, so you get 12. So the next one will be you keep on adding. So you get 24. Okay, so you keep on adding, you get 29. You get 30. Cumulative relative, 3 over 30. This one you get 12 over 30. So you get 24 over 30. Yeah. So you will get 0.1 here. You get 0.4 here. And you get 0.8 here. And continue on. Add on another 0.17. You get 0.97 here. And the last one will have to be 1. Don't write anything here. Leave it blank. Okay, so this is what you have for frequency table. The question also asks you to construct 3 types of graph: histogram, polygon, and ogive. So I prepared for you 3 graph paper, 1, 2, 3 at the end of this. So you can just draw the graph and we will discuss in our next lesson. Okay, so you draw the graph first, then I'll show you what is the outcome, how does it look like, then you can compare with your version. Yeah, so you have to draw it. Okay, now what I want you to do now is look at your tutorial questions. We have done topic 1 today. So you look at the tutorial question, topic 1.1, the first half of the 1, where you have the descriptive and inferential statistics, right? So I will go through with you in detail this particular question because it's not so easy, right? But you can try first. Second question is about random, systematic, stratified, or cluster sampling. So there are 5 scenarios here. You just need to identify what sort of sampling has been taken. 3, discrete or continuous. These are all numbers. Quantitative, they are all numbers. You just need to tell whether the number of laptops, is it discrete number or continuous. Okay, discrete or continuous. The next one, 4, you need to tell whether all these variables given to you, is it qualitative or quantitative. If it is quantitative, then you have to tell whether this data is discrete or continuous. Question 5. There are 4 levels, remember? Nominal, ordinal, interval, ratio. So you go through one by one. Based on what we have discussed just now, you identify if the salaries is a number, so salary must be a number, so it's either interval or ratio. The salary has a true 0. If yes, then it's a ratio. If no, then it's interval. Okay, so like this is what we discussed, right? So you try first. Second half of the topic, shows you the table. Remember the table that we do, yeah, the tabling, right? So you have how many questions or how many numbers particular you have here, 4, 5, 6, 7, 8, 9. So you just fill that here and find out how many times this number happening in there, okay, appearing there. So you just write down and find out the relative frequency. Second question, you are given a set of numbers. So this set of numbers are quite huge in range. So it's not possible for you to list things down like that. So you have to put a group, okay? You have to do a group frequency distribution. Now you want to do a group frequency distribution, you need to find the number of classes. There are 30 numbers here. What is a suitable number of classes you need to have? Then from that number of classes, you decide what is a class width, right? Then you recommend what is a, then you think about what is the first number that you should have in a first class, right? So I told you in the exam, you'll be given the first one. So once the first one is given, you just follow the same pattern to the second one. If there's no under, then the second one should not have under. 51 to 57, then the next number will start with 58. Yep. Then you plus 7, right? Plus 6, right? So you also plus 6 on the second one. Okay, so that's how you fill up the table. Define the remaining class boundaries. That means you filled up the first column. Then construct a group frequency distribution with 5 classes. For this, you just fill up the table. Okay, then construct a histogram and a frequency polygon using frequency distribution. Right. So after you have the table done, you need to draw one histogram, one polygon, and one ogive using the table. Okay, right? So what I suggest is you fill up the table first. Okay, you probably will you draw the histogram, everything for here. You draw the histogram, polygon, and ogive for this one. For this, you fill up the table first. Okay, just in case your table have error, I do not want you to draw the wrong graphs. So next lesson, we will compare the answers in the table. Then you continue to draw the graphs. Okay, so make sure your table is correct first before you draw the graph. So you have 2 questions on that. One question without under, the other question with or under. Okay, whatever you find here, it doesn't matter. When you do up this table, follow this. Okay. Question 4, you may just ignore it if you want, but if you find that no drawing graph is something enjoyable for you, then by all means do so. What I ask you to do is, instead of using the frequency column to draw the graph, now you draw the graph using relative frequency and a cumulative relative frequency. Okay, so question 4, you'll get the same shape of graph as what you have for previously. So it's up to you whether you want to do, but fill up these 2 tables. Yeah, fill up these 3 tables first for next lesson. Then I'll show you what is the final answer. Then you can go back and draw your graph. By the way, the grids for the graphs are provided at the end of this tutorial. Yeah, so you don't need to go and buy graph paper just to draw these few graphs. And don't draw anyhow graph in your paper. You have to draw a proper one. Yeah, so once you have it, please draw a proper one here with a grid. A nice graph. Okay, so there are 6, I think there are a few pages of this graph paper for you. Okay.